Hello, my dear children. Have you watched the videos on properties of inverse trigonometric functions? Okay, now shall we start the exercise 2.3 sums? Right. See the question number 1. Prove that 3 sine inverse x is equal to sine inverse of 3x minus 4x cube, comma x belongs to closed interval minus 1 by 2, comma 1 by 2. Okay, my children, we have to prove this statement. To prove this statement, we use the substitution technique. So, let us consider sin inverse x is equal to theta. By implies sin theta is equal to x. Here, we use the concept of inverse function. Okay, my children, right. Now, to prove this statement, sometimes we can take LHS part and we prove the RHS part. And sometimes we take RHS part and we prove the LHS part. To prove this statement, we are taking RHS. See here, we are taking here RHS. What is RHS? Sin inverse of 3x minus 4x cube. So we have taken sin inverse of 3x minus 4x cube. This is equal to sin inverse of 3 sin theta minus 4 sin cube theta, because here x is equal to sin theta. We are substituting here x is equal to sin theta. Then we get this step. Understood this step, my dear children? Right. That is equal to sin inverse of sin 3 theta. Because if you observe these terms in their brackets, this is the formula for sin 3 theta. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. That is why I wrote here sin 3 theta. Understood this step, my dear children? Right. Here I wrote the formula also in the brackets. Sin 3 theta is equal to 3 sin theta minus 4 sin cube theta. That is why I wrote the previous step. Understood, my children? This is equal to 3 theta, because sin inverse of sin theta is equal to theta. This is the properties of inverse trigonometric functions. By using this property, I wrote this step. Understood this step, my dear children? Right. That is equal to 3 sin inverse x, because theta is equal to sin inverse x. Then we got here LHS. Therefore, RHS is equal to LHS. Hence, the given statement is proved. Understood, my dear children? Right. Now come to the next question. Question number 2. Prove that 3 cos inverse x is equal to cos inverse of 4x cube minus 3x, comma, x belongs to closed interval 1 by 2, comma, 1. We have to prove this statement. Here also, to prove this statement, we take RHS and we prove the LHS. Understand, my dear children? Right. Here also, we are assuming that x is equal to cos theta, by implies theta is equal to cos inverse x. Okay, my dear children, this was written by using the inverse of a function. Okay, my dear children, to prove the given statement, here also we are taking RHS. What is RHS in the question? Cos inverse of 4x cube minus 3x. This is the RHS of the given function. Is equal to cos inverse of 4 cos cube theta minus 3 cos theta. Because x is equal to cos theta, we assumed here x is equal to cos theta. That is why I wrote this step. Understood, my dear children? Right. That is equal to cos inverse of cos 3 theta. If you observe the terms in the brackets, this is the formula for cos 3 theta. 4 cos cube theta minus 3 cos theta is the formula for cos 3 theta. That is why I wrote this step. Understood, my dear children? Right. This is equal to 3 theta. because cos inverse of cos theta is equal to theta. This is the property of inverse trigonometric functions. That is why I wrote this step. Understood this step, my dear children? Right. That is equal to 3 cos inverse x. Because theta is equal to cos inverse x, we assumed in the first step itself. That is equal to 3 cos inverse x. This is nothing but RLHS of the given equation. Understood, my children? Right. That is equal to LHS. Therefore, RHS is equal to LHS. Hence, the given statement is proved. Understood, my dear children? Right. Now come to the question number 3. Prove that tan inverse of 2 by 11 plus tan inverse of 7 by 24 is equal to tan inverse of 1 by 2. We have to prove this statement. Okay, my dear children? Right. Now we take LHS. To prove this statement, we take LHS. What is LHS? Tan inverse of 2 by 11 plus tan inverse of 7 by 24. So we have taken LHS here. If you observe this part, this is in the form of tan inverse x plus tan inverse y. We know that tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. This is the formula in the inverse trigonometric functions. So by using this formula, I am writing this step. Understood, my dear children? That is equal to tan inverse of 2 by 11 plus 7 by 24 whole divided by 1 minus 2 by 11 into 7 by 24. Understood this step, my dear children? Right. That is equal to tan inverse of, if you take the LCM of 11 and 24, we get 264. So we wrote here 264. In the numerator, you get 48 plus 77 whole divided by 1 minus 2 into 7. We get 14 in the numerator divided by 11 into 24. You get 264 in the denominator. Understood this step, my dear children? Right. That is equal to tan inverse of 48 plus 77. What do you get here? 125 by 264 whole divided by, again by taking LCM here, we get LCM is 264, and in the numerator you get 264 minus 14. Understood this step, my dear children? Right. That is equal to tan inverse of 125 by 264 whole divided by 264 minus 14. What do you get here? 250 by 264. Understood this step, my dear children? Right. That is equal to tan inverse of, by striking out the denominators 264 and 264 here, you get 125 in the numerator divided by 250 in the denominator. Understood this step, my dear children? Right. That is equal to tan inverse of 1 by 2 by striking out by striking out by the 125 table, we get numerator and denominator striking out by 125, then you get 1 by 2 here. Understood this step, my dear children? This is equal to RHS. Right. Hence the given statement is proved. Understood, my dear children? Right. Now come to the question number 4. Prove that 2 tan inverse of 1 by 2 plus tan inverse of 1 by 7 is equal to tan inverse of 31 by 17. We have to prove this statement. To prove this statement, we take LHS. What is LHS here? 2 tan inverse 1 by 2 plus tan inverse 1 by 7. We are taking LHS here. Now, if you observe the first term, this is in the form of 2 tan inverse x. There is a formula 2 tan inverse a is equal to tan inverse of 2a by 1 minus a square. By using this formula, I am writing the first term, that is equal to tan inverse of 2 into 1 by 2. A means here 1 by 2. 2 into 1 by 2 by 1 minus 1 by 2 whole square. In this formula I am substituting A is equal to 1 by 2 plus I am writing the second term as it is. Understood this step, my dear children? Right. That is equal to tan inverse of, by simplifying in the numerator you get only 1 divided by 1 minus 1 by 2 whole square. What do you get here? 1 by 2 whole square? 1 by 4. So I wrote 1 by 4 here. Understood this step, my dear children? Plus I am writing the second term as it is. Understood this step, my dear children? Right. That is equal to tan inverse of 4 by 3. By simplifying the first term you get like this, tan inverse of 4 by 3 plus I am writing the second term as it is, that is tan inverse of 1 by 7. Now if we observe this step, this is in the form of tan inverse x plus tan inverse y, isn't it? Right. That is equal to, we are using this formula because these two terms are in the form of tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus xy. By using this formula I am writing this step, tan inverse of 4 by 3, x means here 4 by 3 and y means 1 by 7. So 4 by 3 plus 1 by 7 whole divided by 1 minus 4 by 3 into 1 by 7. Understood this step, my dear children? Right. That is equal to tan inverse of, by taking the LCM of these two numbers 3 and 7 we get here 21. So I wrote 21 in the denominator. In the numerator, you get 28 plus 3. Understood this part, my dear children? Right. Whole divided by 1 minus, by multiplying the numerators, 4 into 1. 4 ones are 4 divided by 3 sevens are 21. I wrote this step. Understood this step, my dear children? Right. That is equal to tan inverse of 28 plus 3. What do you get here? 31 divided by 21. I wrote 21 as it is. Whole divided by, again by simplifying these two terms, by taking LCM of the denominators, we get here 21. In the numerator, you get 21 minus 4. Understood this step, my dear children? Right. That is equal to tan inverse of, in the numerator you get here 31 by 21 whole divided by 17 by 21. Understood this step, my dear children? Right. That is equal to tan inverse of 31 by 17. By striking out the denominators 21 here, you get 31 by 17. That is equal to RHS. This is RHS of the given statement. Therefore, LHS is equal to RHS. We got this result. Hence, the given statement is proved. Understood, my dear children? Right. Now come to the question number 5. Write tan inverse of square root of 1 plus x square minus 1 whole divided by x, comma, x is not equal to 0 in the simplest form. Okay, my dear children, right. We have to write this one in the simplest form. To write this term in the simplest form, we have to use the substitution technique so that the given function becomes a trigonometric formula. So if you observe here 1 plus x square is there. If you substitute x is equal to tan theta, you get 1 plus tan square theta. That is a trigonometric identity. That is why we are substituting here x is equal to tan theta, by implies theta is equal to tan inverse x. Understood, my dear children? Right. Right. Now let us take the given inverse trigonometric function. Now we have to write in the simplest form. By using the substitution technique, we are writing this function in the simplest form. So that is equal to tan inverse of square root of 1 plus tan square theta minus 1 whole divided by tan theta. We substituted here x is equal to tan theta. to write it in the simplest form. That is equal to tan inverse of square root of 1 plus tan square theta. What is the formula? 1 plus tan square theta is equal to secant square theta minus 1 whole divided by tan theta. Understood this step, my dear children? Right. That is equal to tan inverse of square root of secant square theta. What do you get here? Secant theta minus 1 whole divided by tan theta. Understood this step, my dear children? Right. That is equal to tan inverse of secant theta can be written as 1 by cos theta. Isn't it or not? Yes. So I wrote here secant theta is equal to 1 by cos theta minus 1 whole divided by tan theta. How can you write tan theta? Sin theta by cos theta. Can we write it or not? Yes. That is why I am writing this step. Understood this step, my dear children? Right. Here I wrote the formulas also here clearly. Okay, my dear children, that is equal to tan inverse of, by taking the LCM in the numerator, you get cos theta is the LCM. In the numerator, you get 1 minus cos theta. Understood this part, my dear children? Right. Whole divided by, I am writing the denominator as it is, sin theta by cos theta. Okay, my dear children, understood this one? Right. That is equal to tan inverse of, by striking out the cos theta denominators, we get 1 minus cos theta divided by sin theta. Understood this step, my dear children? Right. That is equal to tan inverse of, here in the numerator 1 minus cos theta. 1 minus cos theta is equal to 2 sin square theta by 2. This is a half angle formula. That is why I am writing in the numerator 2 sin square theta by 2 divided by sin theta. See here, sin theta is written as 2 sin theta by 2 into cos theta by 2. This is also called half angle formula. So we are using the half angle formulas in the numerator as well as in the denominator. Then we get this step. Understood this step, my dear children? Right. That is equal to tan inverse of sin theta by 2 by cos theta by 2. By striking out 2 and 2 in the numerator and denominator, and sin theta by 2 in the numerator and denominator, we get this part. Understood this step, my dear children? Right. That is equal to tan inverse of tan theta by 2, because sin x by cos x is equal to tan x. By using this formula, I wrote this step. Understood, my dear children? Right. Now again, tan inverse of tan theta. It is in the form of tan inverse of tan theta. It is a property of inverse trigonometric functions. What is the property? Tan inverse of tan theta is equal to theta. That is why I wrote here theta by 2 or 1 by 2 theta. Both mean the same, theta by 2 or 1 by 2 into theta. That is why I wrote this step. Understood this step, my dear children? Right. That is equal to 1 by 2 into theta means tan inverse x. We assumed in the first step of this question itself. That is why we wrote 1 by 2 tan inverse x. So this is the simplest form of the given inverse trigonometric function. Understood, my dear children? Right.